People eat foods with glucose, like this apple that Frankie believes is very delicious. Yum.
The glucose from the carbohydrate process goes into the small intestines. Now let's take a closer look at the cellular process of the transportation of glucose.
The pancreas senses the higher levels of glucose in the bloodstream and produces insulin as a result, and when binding with receptors, it increases the level of sodium in the bloodstream.
At the cell membrane, the glucose needs to go from a low concentration environment to a high concentration environment. Since glucose molecules are being transported against their concentration gradient, energy is needed. Hence, it is an active transport. The energy needed that drives the glucose against the concentration gradient doesn't come directly from ATP, but rather from the energy stored in a sodium ion from the increased insulin. Since ATP isn't directly fueling the process, it is called secondary active transport. To pump glucose against the concentration gradient, the pump takes both sodium and glucose from outside the cell and deposits both of them in the cell. A pump that transports two substances in the same direction is called a symport protein. The sodium ions that enter the cell are later returned to the outside via the sodium-potassium pump. The process is called primary active transport that creates sodium and potassium gradients at the expense of ATP.